Please join immediately. Okay, let us start. Ask all your friends to join immediately. I want you all to join. See, again, the issue of attendance only comes when you people join bit late. Okay, so fast, you join immediately. Please confirm regarding the board visibility. Board is visible. Board is visible. Whatever I have written on the board, whether it is visible or not, please confirm. Say someone, one of you please reply either in a WhatsApp or in this chat message itself. Please reply back. The board is visible to you or not. The two lines what I have drawn on the board, they are visible. Okay, thank you. Then I'll start. Okay, so in the last class we have discussed regarding, say, line coding. Yes, so it is a continuation of that, and I told you that there are, say, 5 different encoding, line coding schemes. Okay, so first of them is these are the broader categories. Okay, these are the broader categories. First one is unipolar. Fine. First one is unipolar. Okay. Second one is polar. Look at the names. Simple. Easy to remember. So you remove this uni, keep only polar. This is the second scheme. Third one is bipolar. Yes. Fourth one is multi-level. And last one is multi-transition. Okay. Basically, we are concentrating on these 3. Okay. According to your syllabus, we need to concentrate on these 3. Fine. Pradeep, what is that? Screen, what is screen? What do you mean by screen? I am not getting. The board is not visible. I think many of them they replied saying yes. Pradeep, USN 58, please reply. I think it is clearly visible when I see the one more, say in my another machine, so it is visible. It is visible, man. Okay. And now we were talking regarding these five schemes and we are concentrating on these three. Okay. Polar, unipolar, bipolar. Okay. So what exactly the unipolar means? The way in which the voltage levels what we use. Okay. Basically this classification is done based on the voltage levels what we use. Okay. How many voltage levels we use and with respect to time say reference, how exactly the voltage levels will be used, all those issues we will going to discuss here in this category. Okay, now first scheme is talking regarding the first unipolar, we are talking about NRZ scheme. Okay, what exactly the NRZ means? Non-return to zero. Non-return to zero. I am going to describe them how exactly they are. And second one is in case of polar, again you will go to come across non-return to zero, NRZ. Okay, NRZ. There is one more scheme known as RZ scheme. Okay, RZ scheme. Yes. So third one is biphase. Okay, so these are the three schemes which we will going to discuss under the polar category. Okay, so under the polar category we talk regarding these three schemes, and in bipolar again it is AMI and pseudo rudimentary. Okay, there is a little difference between this. Okay, I simply PSR I will write because of the space reasons. Okay, so it is AMI and pseudo rudimentary. Okay, pseudo rudimentary, both of them almost same, only way in which 1 and 0s are getting represented, that is different. Okay, anyway we are not interested in multi-level and multi-transition, so I will not going to discuss regarding that. Okay, so these are the schemes which we are interested. Okay, now already you are aware how exactly we will going to say analyze these schemes based on what criterias. The criterias also I told you yesterday, that is presence of DC component. Okay, so presence of DC component. How much say what is the DC component, whether it makes a DC to be generated or not. Okay, so that is one. Actually first one what we started is baseline wandering. Okay, so we talk regarding baseline wandering. Third thing is self synchronization property. Yes, self synchronization property. Okay, so these are the certain criteria based on which we are analyzing them. Okay, so apart from that, say error detection property, built-in error detection, error detection property. Okay, the next one is say immunity to the noise. Okay, so how exactly it will deal with the noise. Okay, deal with the noise. And last one is complexity. Okay, last one is complexity. Okay, last one is complexity. So these are the 5 criteria based on which we are analyzing the encoding schemes or those line coding schemes. Okay, so whenever I talk about any of the scheme, so I will try to analyze using say either by all properties or by few of them. Okay, the analysis will be done based on that. So first we'll start with unipolar scheme. So in this, that is NRZ. So I am going to call it as unipolar NRZ because the NRZ name is also there in the polar scheme. So we'll call it as unipolar NRZ scheme. Okay. So in unipolar NRZ scheme, what happens here you see. So this is a reference. Okay. So either I will use a positive voltage or a negative voltage for representation of bits. Okay. So here the voltage is of only one polarity. So either it is positive or negative. Okay, so for understanding reason, because you have come across say many of these kind of representations, so I'll use positive voltage to represent a 1. Okay, so I have actually two voltage level. One is V, another one is say your 0. Okay, this is a timeline. Okay, with reference to time I am drawing these things. So these are my bit durations, that you keep it in mind. All these bit durations are same. This dotted line shows me a bit duration. Okay, for this much period it has to be in that particular state. Okay, now I talk of representing 1. So 1, it has to stay in a V state. Okay, to represent 1 for this much of duration. For this much of duration, this duration I am going to call it as T. Okay, so I am going to call it as T. So it has to stay in that state for T seconds. So thereafter it will come down. So that means the next bit representation will start. So if it is 0, it stays there. Yes, again if next is 0, it will stay there. Next bit is 1, so it again goes up to V and come down after T. Okay, so this is the kind of a representation for 101. Now see why we are calling it as unipolar. Look at the polarity. It is using either positive or negative voltage to represent one of them. So we are not using both. Both positive and negative are not used here. Only either of them. Okay. So understanding reason I have taken a positive voltage. So it is only one voltage level and other bit is represented with the help of reference. So with respect to reference, I am using only one voltage level. With respect to reference voltage, I am using only one voltage level. Okay. So this is what is unipolar. Now when you look at this scheme, okay, when you look at this scheme has a few advantages. The advantage is simplicity. Advantage is simplicity. Okay. And again, non-return to 0. Why I am calling it as non-return to 0? NRZ, unipolar, non-return to 0. Say, look at this duration T. Okay, for which it stays in a high state. Okay, so but when it comes to representation of a 0, it comes back to a 0 voltage and it is representing the 0. Okay, but during the representation of 1, it is not coming back to a 0. So in this duration, it is not coming back to a 0. In some of the schemes, we have that kind of options. We have that kind of options. So for that reason, they call it as non-return to 0 scheme. Non-return to 0 scheme. Okay, please keep this in mind. Okay, so it does not have that scheme of returning in between the bit duration to a 0. Okay, so that is the reason we call it as non-return to 0. Okay, so this is a very simple representation. The disadvantage of this, can anybody? What is the disadvantage? Any idea regarding the disadvantage? Okay, very simple scheme, that is a big advantage. Okay, when it comes to series of zeros, just take this case, series of zeros. Okay, if your information is of the type, say initially few zeros or a few ones, continuous zeros or a continuous ones. So what way that it will going to represent? It will be a straight line. Even in case of 1, it is a straight line. Okay. So now what will happen? So if it is straight line, it will create the first problem of baseline wandering. Series of zeros, if it stays at one voltage level, okay, so it creates a baseline wandering problem, because when you talk of say finding, because receiver decodes based on the whatever the input stream it gets, it is analyzing the say with the help of these things, it is trying to mark itself some reference. Based on that, it is identifying whether it is a 0 or 1. So if it is continuous 1 or a continuous 0, the baseline will shift. If it is continuous 1, it will be shifted from here to here. So it becomes V. V will going to be the reference voltage. So then it will have a confusion. Okay, if anything lesser than a V will be treated as a 0. So these type of possibilities are there in a NRZ scheme. Okay, so baseline wandering problem. And if there is a baseline wandering problem, naturally it will go to create a DC component problem. Okay, it will create a DC component problem. Third property, does it have a synchronization property? No. Why? You see, the same situation when series of zeros, or if it is series of ones, the representation will go to like, it will stay as a straight line. Yes, so this is showing the presence of DC component in the representation. This is the one which is changing the reference baseline, okay, baseline reference value. Okay, so third case, you see, if it is straight line, if there are no pulses, it will create a confusion to the receiver for synchronizing with the sender. Yes, so this is what is the problem that is in an NRZ scheme. The biggest advantage is simplicity. Okay, biggest advantage is simplicity. Okay, next is unipolar scheme. Polar schemes. Next is polar scheme. Okay, so in this polar scheme, first I will start with, say, that NRZ scheme. Okay, in polar we have an NRZ scheme. In this NRZ scheme, now see, I am talking about the polar scheme. Okay, polar NRZ scheme. Okay, in this NRZ scheme, I have again two different ways of representation. One, I am going to call it as NRZL. Okay, NRZL. So non-return to zero level. L means level. Next is NRZI. Okay, non-return to zero inverse. Okay, non-return to zero inverse. These are the two different schemes which we use, okay, in polar NRZ case. Okay, so these are the two versions of this polar NRZ, L and V. So we will see to it. Okay, what are the advantages of two different schemes? Again, there is nothing different. This NRZ L scheme is not much different from that of your, say, NRZ I scheme. Unipolar NRZ scheme. Unipolar NRZ scheme. Okay, so there is a very little difference between polar NRZ and unipolar. Okay, so in polar NRZ we need a two voltage levels with reference to with respect to reference voltage. So with respect to reference voltage, I need a two voltage. Okay, one is plus, another is minus. Okay, so here, say 0. Okay, I will try to stick to a, say, representations that is used in your book. So again, it is not mandatory that positive voltage to be used for representation of a 0. Okay, so either of them can be used. Okay, in some of the books, Andrew Tenenbaum, he starts with positive, this plus V, he uses it for one representation. Okay, so anyway, in Farouzan book, he starts with 0, so I will stick with that. Okay, so 0 will going to be represented by one voltage, that is positive in my case, and 1 will going to be represented by another voltage, that is negative. Again, say there is no movement during this bit duration. So this is my bit duration. During this complete duration, it will stay in that voltage level. Okay, so 1, again 0. Fine. So this is my representation of 1 and 0. Okay, now this is about NRZ, say, polar scheme. In NRZ L polar scheme. Okay, so where the representation is almost same as that, but the biggest advantage, what exactly the advantage over here? So in case of polar NRZ, okay, so in case of polar NRZ, okay, the power, okay, the normalized power calculation, okay, it will be less compared to that of your polar. Say here in polar scheme what happens, unipolar scheme what happens, normalized power will going to be calculated this way, half V square half V square. Okay, so and when it comes to a zero representation, it becomes half into 0. So two voltage levels. Okay, so one is V, another is 0. So this leads to a normalized power equal to half V square. Okay, which is a problematic when it comes to a unipolar. So this half V square is a issue over there. Okay, for that reason we shifted here for a two voltage level. One is half plus V square, another is minus V square. So if I change it, the average power requirement will go to be say 0. So that will be the advantage over here. Okay, so that will be an advantage. For that reason, two voltage levels will go to be used. Okay, clear? Because that positive and negative voltages will go to cancel the effects. Okay, that is what is the meaning of it. Okay, both positive and negative voltages will go to cancel with each other. In the end, say it will go to be at a 0. This is what is an advantage compared to that of unipolar NRZ scheme. Okay, so here again the voltage levels will be used for representation of bits. Voltage levels are used to representation of the bits. Okay, next is unipolar NRZ scheme. Okay, see, too many schemes, it may create a problem. It may create some kind of a confusion. So say please listen these things carefully, and after this I am going to give you one small exercise. Okay, so I am going to give you a bit stream. I will ask you to say represent that bit stream using these techniques. Okay, so we'll see to it. Next is NRZ scheme. Okay, look at this scheme. Okay, look at this scheme. Again we have a bit duration like this. Okay, so in this case also your voltage, we are using two voltage levels, plus V, minus V. Yes, the advantage, as you know, that it gives you an advantage when it comes to a say normalized power. Okay, so normalized power in this case it will going to be a 0. Fine. Now, okay, how it is different from NRZ you see. So in this scheme, okay, I talk of say representing same bit pattern, that is 0, 1, 0, 1. Okay, 0, 1, 0, 1. Clear? Okay. Now, this is the beginning of the bit. This is the beginning of the bit when it comes to a 0 representation. Okay. So, there is no transition of voltage. Look at the thing. So, voltage is not moved. So, I'll start with positive voltage. Okay. So, there is no transition of this voltage. So, it stays here. So, I'll represent it by say empty bubble. Okay. I'll represent it by empty bubble. Clear? But when it comes to a representation of 1, so there will be a transition. I'll show it by dot. Dot indicates inversion. Okay. So the voltage gets inverted. Transition here indicates the inversion. Okay. So it is moving. Now see. So beginning of 1. So this bit 1. You are talking of representing 1 now. Okay. So to represent a 1, what happens? It transits from this voltage level to another voltage level. It transits from this voltage level to another voltage level. You see, it moves from this voltage level to this. So I am showing you with arrow mark. I have shown that with the arrow mark. So this happens at the beginning of the bit. So this is the beginning of 1. So during that time, this transition takes place. Clear? So next it stays. After doing the transition, it stays in the other voltage level for a bit duration. Okay, that is for T. T duration, it will stay in that voltage level. So only at the beginning it makes that movement. It moves from one voltage level to another voltage level, which we call it as inversion. Understood? Okay. So next, see again, a 0 comes. Okay, next bit is 0. Now what has to happen? No inversion, absence of inversion. Absence of inversion is 0. So again, see, no inversion. It is at this voltage level. You see, it stays in this level itself. Look at the scheme. See, it moves from here to here when it comes to representation of 1. When it comes to a representation of 0, no question of transition. but it stays in that level. Okay. Now here voltage level does not have any say effect here for representation of 1 or 0. Okay. The presence of transition or the absence of the transition will indicate whether it is 0 or 1. So 0 will going to be represented with the help of absence of transition, 1 will going to be represented by with the help of presence of transition. So whenever there is a transition, that is leading to a representation of 1. Whenever there is the absence of transition, that is leading to a representation of 0. Now when it comes to 1, again you see the action what happens here. Okay, so I'll try to use some other pen. You see, again it gets inverted. Again it gets inverted. You see, this is moved from lower side to a higher side. So you see, when it comes to this voltage 1, it was stayed in a negative voltage. Now when it comes to representation of this one, okay, it stays in a positive voltage. I mean, it goes to a positive voltage and it stays there. I hope it is clear. Any doubt? Any doubt in NRZ-I scheme? Any doubt in NRZ-I scheme? You are free to ask. Put your questions in comments. You are free to put your questions in the comment section. I hope you understood this. I think all of you have a pen and pencil with you, pen and notebook with you. If you say yes, I'll give one assignment to you. Okay, anyway, I'll discuss over here and say the remaining things. Okay, I'll going to give that say question, which is kind of a assignment for you. Okay, so most of the times in question paper they will give you some bit stream. Okay, so with the help of that bit stream you have to represent those schemes. Those bit streams are required to be represented in the signal form. Okay, in the signal form, that encoding they will be asked in a question paper. Okay, by giving some question say some bit pattern. Now we'll discuss regarding the advantage and disadvantage of NRZ and NRZ-I. Okay, so the only advantage with NRZ-L, is that normalized power will going to be 0 in case of NRZ-L level. Okay, compared to that of RZ scheme. But or otherwise the problems that are associated with the RZ, unipolar NRZ scheme. Now I am trying to compare two schemes, that is two NRZ schemes. So here this is level in a polar, here it is unipolar. Okay, so these two schemes are almost same, there is no problem. Almost they are giving the same disadvantages. Only advantage of this scheme over this is that normalized power, it becomes 0 over here. But otherwise here it is having a half E square value. Okay, but otherwise the presence of DC component, say baseline wandering, all those problems will going to be seen in these two schemes. Okay, so this is polar NRZ-L scheme. Okay, so when it comes to a stream of zeros or a stream of ones, you see the representation of NRZ-L and NRZ almost same. Unipolar NRZ, it remains same. Okay, so they create a DC component, yes, that will lead to a baseline wandering, yes, the absence of self synchronization property, all those things will be seen in these two. Okay, now we'll talk of comparing NRZ-I scheme with respect to these two. Okay, with respect to these two, NRZ-I scheme with respect to other two. Okay, even though it is polar scheme, okay, it has advantage over polar NRZ-L scheme. You see why? say for one of the bit stream, it eliminates the problem of DC component baseline wandering, which is that one. If there are series of zeros, that problem will continue as it is. But I'll talk of first series of 0 and then I'll talk about series of ones. First we'll see the disadvantage, then we'll talk about the advantage. Okay. So the disadvantage that what we have seen in other two schemes, it will remain when it comes to a series of zeros in case of NRZ I scheme. Okay. If I have say series of zeros, if my information is say of this type, in this situation, my NRZ I scheme, okay, will going to generate a signal of this type, say absence of transition, absence of transition, absence of transition, and so on. So again you see, it is a straight line. It is a straight line. Clear? But the biggest advantage is that, you see, if I talk of series of ones, if the information contains series of ones, we are talking about these extreme cases, because for other cases automatically there will be a kind of a waveforms and all, so that will eliminate most of the problems. But these are the certain extreme cases where they will not function properly. Okay. So now when it comes to series of ones, in case of NRZ I scheme, what happens you see? So at the beginning it will transit, it moves from this positive voltage to a negative voltage. Clear? So it stays in this negative voltage for duration of t. Okay. So next bit is what? Again it is 1. So at the beginning of this bit, it transits, it moves from this side to this side. Look at the C. So look at these arrow marks. These arrow marks are representing these bit values. So since it is 1, transition. Okay. Since it is 1, it is a transition. So it stays there. Next bit is 1 again. So transition has to happen. Okay. Transition has to happen. Okay. It stays in this voltage, in this, say, in this state for t duration. Okay. So time duration is t seconds. For that duration it will stay. Again the next bit is 1. So what it will do? It will do the transition. Yes. And stays in this level for t duration. Okay. So like this you see the advantage when it comes to a representation of 1. So because that 1 is getting represented by presence of transition, so it is generating or it is eliminating the problem of, say, the DC component present. Because once it starts oscillating like this, okay, once it starts moving from one voltage level to another voltage level, the problem of that, say, baseline wandering, DC component presence, all those things will going to be eliminated because of this oscillations. If there is an absence of oscillation, it will lead to what? It will lead to one kind of voltage. Either it will be a 0 or 1 or negative voltage. Okay. So this will create the problem. That means that type of representation will create a problem. So at least for this kind of a bit streams, we eliminated that problem. Okay. But when it comes to a series of zeros, again that problem will persist. That problem what we have seen in the NRZ, unipolar NRZ. Okay. Next is the bipolar scheme. Okay. So what I mean, say biphase scheme. Okay. So which is a third category of this method, that is biphase scheme. Okay. So there are three versions of polar NRZ, polar scheme. One is NRZ L, second one is NRZ I. Okay. And a third category, I mean in this polar scheme we have, say, third category, that is biphase scheme, which is also part of this polar, biphase. Okay, what exactly this, say, biphase means? Okay, so this scheme mainly say eliminate the problem that is noticed in these two schemes. Okay, it is mainly to eliminate the problems that are noticed in the first two schemes. Okay, what exactly it will do? Okay, what exactly this schemes do? Okay, so there is one more scheme, that is return to zero. We'll discuss it. Okay, first biphase scheme I will discuss. Okay, so first I will discuss return to zero, because I need a support of return to zero scheme to represent for go for a biphase scheme. Okay, so these two are a newer scheme which are not same as this. Okay, so we'll talk regarding first RZ scheme. What exactly the RZ scheme? Return to zero scheme. Okay, this is also a category of polar scheme. Okay, so that polar means we need a support of two voltage levels. Polar scheme means we need support of two voltage levels, that is plus V minus V. In this polar scheme, we are talking regarding return to zero scheme. Return to zero scheme. What exactly the return to zero scheme means? Okay, so I'll take again some bit stream. Okay, this is my information stream. How exactly this RZ scheme will represent these bit stream? Okay, this information. Okay, so I'll start with, say for a 0, I'll start with a negative voltage. Okay, so as I said, again there is not a mandatory thing. Say either you start with a positive or negative. Sometimes they mention. Okay, so which voltage level to be used for 0, which voltage level to be used for 1. Okay, and again as I said, I will try to stick to your book notations. Fine. So it starts with negative voltage for a representation of 0. Again, it uses support of level here. It uses the support of level. Okay. So negative voltage level is used to represent a 0. Positive voltage is used to represent a 1. Okay. So you start with negative. Okay. Now see why we are calling it as a return to zero scheme. After the half bit duration. Now see, this is the complete duration of this bit 0. Okay. So this is the complete duration for which we need to represent a 0. Okay. See, it starts with negative voltage after half bit duration, after t by 2 seconds. If this is completely, if it is t, if this duration is t. Okay. So after t by 2 seconds. Now see, this is the time period where it is half. T by 2. What happens? There will be a transition from negative voltage to a 0. So this voltage level to 0. It will move to that side. Okay. And again it will not go to this side. It stays here. It stays here and remains on 0. Now see, after half bit duration stays in this positive voltage level for half bit duration. Okay. So thereafter it comes back to 0 again and stays in that 0 for remaining half bit duration. Okay. Now see, the same one is used. Same one is used to represent by using a 2 voltage level. When it comes to a 0, it is also getting represented by 2 voltage levels. So every time it is coming back to the reference. Every time it is coming back to the reference. Now next bit is 1. Okay. Next bit is 1. So again it has to use a positive voltage level. So it moves. So you see this movement moves from 0 to positive. Yes. It stays in this level for half bit duration. Comes back to 0. Yes. Stays in that 0 for remaining half. And when it comes to a 0, it moves to a negative voltage level. Stays there for half bit duration. Comes back to 0. And stays there. Okay. So this is how your RZ scheme is. Okay. So anyway, it is 10:15. I mean 10:55. Okay. So if you had any doubts in RZ scheme, Ramesh Sanadi, any doubts in RZ scheme, please reply in say comment section. If you had any say doubts regarding this particular scheme, please reply. Ramesh Sanadi, I not asked you people to put your USN now. Any doubt? Okay. I hope you don't have any doubts. In case if you had still any doubts, you are free to discuss either through WhatsApp or through Google Meet. Tomorrow I will try to arrange one Google Meet session to know your difficulties. At least we are going to have say some kind of a interactions with you. Okay. So tomorrow afternoon I will fix one time. So that time I request all of you to be there and you are free to discuss your issues. Okay. Tomorrow I am going to have one Google Meet session through which we will going to discuss our all the issues. Okay. If you had any doubts or difficulties, you are free to discuss over there. Now I will give you a 5 minutes time. Within that 5 minutes time, you put your USN in a comment section. Do it fast. Put your USN in a comment section, that will be treated as your attendance. So within 5 minutes you have to finish it off. Within 5 minutes you have to finish it off. Please start entering your USN in comment section. Okay. Thank you very much. Many of you are attending only for the sake of attendance. All of a sudden that number get changed. Okay. I hope all of you have entered your USN. I'm going to end the stream. I think you have one more class after this. You take some 15 minutes break. Okay, so I think at 11:15 the next class will going to start, it seems. Okay, so please, I'm going to end the session over here. So you take a break, have a tea or something, then attend the next class. Thank you very much for attending the class. I'll end the discussion over here. Please go through these schemes. These are very important from the point of view of your eye. Okay, in the Google Meet session also we are going to discuss regarding the question paper pattern and other issues. Please join that Google Meet session. Either it will be today afternoon or it will be tomorrow afternoon. I am going to put the message. I am going to put the message. You are free to discuss all your issues over there. I'll end. So still 2 minutes time is there for you to enter your USN. Anybody has left out, please enter your USN in comment section. Don't send your USN through WhatsApp. Today I am using this comment section for attendance. Mega Kannur, you don't have a USN? No, I have shown RZ by using 0. You want me to show it by taking 0? So the representation one which is shown on the board is by taking 1. 1 as a positive, 0 as a negative. Shivani Chavan, you want me to show by taking a 0 as positive? Shivani, sorry, Shashi Chavan. Shashi Chavan, please reply. Okay, okay, I'll show it in the next class. I'll end the stream. Okay, now time up. I'll end the screen. Any USNs entered after this end of session will not be considered.